Hello, and welcome to Section 1 of the Mapping and Measurements module, part of the How to Manage Your Forest online series. My name is Tristan Huff, and I'm an Extension Forester with Oregon State University. I'll be your instructor for this module. The How to Manage Your Forest online series is all about helping you achieve your goals and objectives for your property. Now, a good inventory can help you meet your goals by answering some important questions. These questions include: what do you have in your forest? Where are those resources located? How are those resources doing? And do you need to make any changes in order to help you meet your goals? So, what do I mean when I say a forest inventory? Basically, an inventory is simply an account of what you have out in your woods. This could include things like the vegetation, whether that's mature timber or young growing trees, or even understory vegetation. It would also include wildlife, water features like streams and ponds. You might also want to include in your inventory the infrastructure that helps you manage your woods. This would be things like roads, trails, culverts, etc. An inventory might include special sites, which are simply areas on your property that have special significance either to your family or in a general historic sense. Things like pioneer cemeteries, old homesteads, etc. Beyond these resources, you might also want to inventory some more negative aspects, things like invasive species or insect and disease outbreaks. Now, all these things could be included in an inventory, but you'll want to pick and choose the ones that are important to you so that your inventory is working for you. The goal of this module is to give you the tools and resources you need to successfully inventory your woods. We'll start by talking about the land survey system. Then we'll get into a discussion of the various maps and aerial photos that are available to help you in your management of your woods. In part 2 of this module, we'll walk you through the step-by-step process of actually creating a forest inventory. Finally, we'll talk about some of the vocabulary and methods used to measure forest products that come off your property. The Public Land Survey System is the method by which the United States were initially divided to facilitate turning public lands over to private ownership. When our country was initially surveyed early in its history, the Public Land Survey System was used to divide ground up into smaller and smaller squares. This system of grids within grids is still used today to delineate individual tax lots and to determine private ownership. To find out where your property fits within the Public Land Survey System, just look to your deed. Here you'll find what's known as a legal description. An example one we have here reads: the southwest quarter of the southeast quarter of Section 21, Township 21 South, Range 11 West, Willamette Meridian, Douglas County, Oregon. We'll decipher exactly what this means in the next few slides. First, let's start with that Willamette Meridian part. Meridians break the country up into large grids which form the basis for the Public Land Survey System. If your property is within Oregon, then you are in the Willamette Meridian. All meridians have what's known as an initial point, which is the starting spot where all surveys for that meridian originated. The initial point for the Willamette Meridian is a place called the Willamette Stone. Just like its name implies, it's a big rock that sits in a park southwest of Portland. You can go and visit it if you want. As I mentioned earlier, the Public Land Survey System is basically a system of grids within grids. We just talked about meridians, which are the largest grids in the system. Now, meridians are broken down further into smaller grids known as townships. Townships are 6 miles square, and they're labeled based on their location relative to the initial point of the meridian. Townships are called by their position north and south. We call this their township. And we label them based on their direction east or west from the initial point. We call this the range. This might not make sense, but let me explain it further here with an example. This township is 2 down and 4 east of the initial point in the grid of townships. So we would label this one Township 2 South, Range 4 East. This township is southwest of the initial point. We would call this township Township 4 South, Range 5 West. Okay, let's zoom in even further. Townships are broken up into 36 equally sized sections. Now, since a township is 6 miles by 6 miles, each section is going to be 1 mile square. And that 1 mile square section contains 640 acres. Sections are numbered based on where they are in the township, and that numbering always starts in the northeast corner of this township, with 1, and then zigzags down the township until you reach the southeast corner at section 36. This might seem like a strange way to number the sections, but remember those surveyors back in the day were walking through the woods as they surveyed the ground, and this is the route that they took as they surveyed each township. These 1 mile square sections are further divided into quarters with 160 acres each, half quarters with 80 acres each, and quarter quarters with 40 acres each. This breakdown into quarter quarters, half quarters, and full quarters is why most tax lots nowadays contain multiples of 40 acres. So we've seen the breakdown from meridians to townships to sections, and finally to tax lots within sections. So this breakdown of grids within grids is the public land survey system in a nutshell. Now, I've been using the term acre a lot to talk about area, and I want to articulate exactly what an acre is. We all probably have a pretty good sense of what an acre of ground looks like, but in numbers, an acre equals 43,560 square feet. This equates to a square with about 208 feet on each side. We can also think of acres in terms of chains. Now, a chain is a commonly used unit of length used in surveying and forestry, and each chain contains 66 feet. An acre contains 10 square chains. Good maps are an important part of any forest inventory. They define your property boundaries and help locate resources within your woods. Maps can also help you quantify features in your woods. For example, they can help you determine how many miles of roads you have, or how many acres of mature timber you own. There are many different types of maps you can use in your forest inventory, but we're going to talk about the most commonly used ones. Plat maps, topographic maps, aerial photos, and soil maps. First, let's talk about plat maps. Plat maps are the official maps used to graphically display tax lots. They usually contain one section per map. Remember, sections are 1 mile square. Sometimes, when there are many small tax lots in a small area, such as in a residential development, sections can be divided up into multiple plat maps, so they're easier to read. Now, there are lots of different features contained in a plat map. These include roads, physical features like rivers and lakes. Plat maps also contain public land survey information. Basically, they tell you what township and section you're in. And plat maps also contain ownership boundaries. So basically, each tax lot will be drawn out on the plat map. This lets you know where your property boundaries sit in relation to your neighbors. Now, these maps can be found either at your local assessor's office or online. Topographic maps are useful because they contain information on the terrain. Contour lines follow the slope and show areas of equal elevation. The interval is the elevation difference between these lines. When the contour lines are close together, that indicates a steep slope, whereas widely spaced contour intervals show areas that are not as steep. Streams are going to show up as V's, the point uphill, whereas ridges are going to show up as U's, the point downhill. Aerial photos are very useful when managing your woods. You can use them to determine what types of vegetation cover you have. You can locate roads and landings that don't show up on any map. And you can also locate areas of concern, like understocked areas or disease outbreaks. Aerial photos are available from lots of different sources. You might look to local land management agencies, such as the Oregon Department of Forestry, Bureau of Land Management, or the U.S. Forest Service, because sometimes their land might border yours, and they might have aerial photos that cover your land. The Natural Resource Conservation Service, or the Farm Service Agency, often has aerial photos available to private landowners to use in their land management. Or you might also talk to your Oregon State University Extension agent. You can also look online. There are lots of good sources there for quality aerial photos, including places like Google Earth, Bing Maps, or any of the other online mapping sources. They often have fairly high quality and recent aerial photos available. Soil survey maps are a specialized type of map that contain information on the different soil types found within your county. You can use these maps to figure out what soil type is found on your specific property. Once you know what soil type you have, you can use this information to help guide your forest management. These soil survey maps are available through your Natural Resource Conservation Service office or from your Oregon State University Extension office. Soil survey maps can be found in the old soil survey books like the one on the left, or you can go online to Web Soil Survey to find the same information. Using Web Soil Survey, you can create custom maps that show the different soil types on your property, as well as different characteristics of that soil relative to forest management. A management map is probably the most useful map to you because it's one that you make. These maps can be either hand-drawn or computer-generated, but the key thing is that they contain features that are important to you based on your management needs. You might include things like timber stands, roads, water features like streams and ponds, or even fence lines. The key thing is you include things on your map that are going to make it more useful to you in your management. As I just mentioned, management maps can be either hand-drawn or created using the help of a computer. There are lots of computer programs available that can help you make a very high-quality management map. Most of these programs are what we would call a GIS, or Geographic Information System. These programs take geographic information and allow you to make complex analyses and to create maps. While some GIS programs are fairly expensive and difficult to learn, there are some free, user-friendly options available online. GPS units are handheld devices that use satellites to pinpoint your location on Earth. These can be useful when combined with computer mapping because they help you accurately locate features on the ground. Remember, though, that since these devices use satellites to track your location, accuracy can be quite poor under a forest canopy. While a GPS can be a very handy way to navigate around your woods, compasses are still a great low-tech solution. We won't go into the details of using a compass, but I wanted to discuss magnetic declination, which has a big influence on how your compass works. Basically, the issue is that there are local differences between true north, that's the direction to the North Pole and the way most maps are oriented, and magnetic north, which is where your compass points. The problem is Earth's magnetic field doesn't arrange itself in a perfect north-south direction, so there are important local differences in the direction your compass points. This difference between true north and magnetic north is known as magnetic declination. In Oregon, declination is always going to be to the east, and it's going to range between 14 degrees in the extreme southeast of Oregon and 17 degrees in northwest Oregon. That's a pretty big difference, and it'll lead to inaccuracies if you don't calibrate your compass before using it. To figure out exactly what the declination is in your area, you can either look at USGS topographic maps or go online where they list the exact magnetic declination for your area. Okay, let's look back on what we've learned so far. We've learned that an inventory is an essential part of any forest management plan. We talked about the public land survey system and how it locates your property in the whole scheme of things. We also learned about different types of maps that can help you in the management of your woods. In part 2 of this module, we'll be learning how to create a forest inventory. We'll go through the process step by step, learning about creating a management map, designing your inventory, and measuring trees. Also in part 2, we'll talk about measuring the forest products that come off of your property. Thanks for listening. I hope you'll join us for part 2 of this module.